Greetings. Welcome to our 14th episode of the FGI podcast series. My name is Tim Stark, and I am a professor of civil engineering at the University of Illinois at Urbana-Champaign.
Hello, everyone. My name is Jen Miller, and I'm the coordinator of the Fabricated Geomembrane Institute, or the FGI.
On today's episode, we are going to focus on selection of geomembranes for containment purposes or applications.
Sounds great, Tim. Let's start with some basics. How do you define a geomembrane?
The easiest way to do that, Jen, is to go to ASTM D4439, which is a standard terminology for geosynthetics. So it defines many types of geosynthetics, one of which is geomembrane. And so ASTM D4439 defines a geomembrane as, quote, an essentially impermeable geosynthetic composed of one or more synthetic sheets. Now, impermeable in that definition means a hydraulic conductivity or transmission rate through the geomembrane of 1 times 10 to the minus 12 to 1 times 10 to the minus 15 meters per second. And that's why the terminology says essentially impermeable. That is an extremely low transmission or hydraulic conductivity rate. For comparison, a compacted soil liner used for a landfill application would have a hydraulic conductivity of less than 10 to the minus 9 meters per second. So a geomembrane is 3 to 6 orders of magnitude. So 3 orders of magnitude is 1,000 times. 6 orders of magnitude is 1,000 times 1,000. I'm going to have to think about that. Times less permeable than a compacted soil liner. So without defects, a geomembrane is extremely impermeable, and 6 orders of magnitude is 1 million times less permeable than a compacted soil liner.
Okay, wow, that's great. So what is the primary function of a geomembrane?
The primary function is containment of liquids and or gases. And I mentioned gases. Most people think of geomembranes and think of only liquids. But gases is a very important application for geomembranes. For example, geomembranes can be used for odor control at agricultural areas, livestock areas, landfills. And it can also be used for control of greenhouse gases such as methane, carbon dioxide, carbon monoxide, and other gases. So don't forget, containment includes liquids and gases as the primary function of a geomembrane.
Okay, yes. So what are some common geomembranes?
There are actually a number of geomembranes, and they all have little acronyms for them. I'll give maybe 5 or so, 10 or so. Chlorosulfonated polyethylene, CSPE. Ethylene interpolymer alloy, EIA. Ethylene propylene diene, EPDM. EVOH, ethylene vinyl alcohol. PVC, polyvinyl chloride. Reinforced flexible polypropylene, or FPP-R, high-density polyethylene, HDPE, linear low-density polyethylene, LLDPE, polyurethane, and so those are just some common types.
Right, okay. So with containment being the primary function, what is the most important aspect of geomembrane design?
The most important aspect is chemical resistance. So whatever the geomembrane will have to contain, whether it's a liquid or gas, the designer must make sure that there is appropriate chemical resistance. In other words, the liquid it is containing cannot degrade the geomembrane and make it more permeable. And there's a common test. It's usually ASTM E as in Edward 96, standard test method for water vapor transmission of materials, very common for specification of geomembranes. And in this test, you can use distilled water, thus the water vapor transmission, or you can actually use a site-specific solid, which is really recommended. So if there's any concern about the chemical resistance of the geomembrane, you can conduct E96 with that particular solvent or contaminant, such as oil and gas, or leachate from a particular landfill or manufacturing process, and conduct this test E96 with that particular fluid. And in E96, there's two ways to conduct the test. One is called the desiccant method, and the other is the water method. And I'm really describing the water method. And in the water method, you have a little cup or container. The geomembrane is placed over top of the cup or container, and distilled water is in the cup, and over time you measure the weight of that distilled water with time, and that tells you how much is able to transmit through the geomembrane, and that is called the water vapor transmission. Of course, if we fill the cup or pan with site-specific solvent, we weigh that cup with time, and that tells us how much the solvent transmits through the geomembrane with time. The manufacturers of the various geomembranes usually have conducted these tests, and so you can ask the geomembrane manufacturer for available data on particular contaminants, and maybe they've already conducted the test. In addition, the public literature has a number of chemical resistance charts, and these are tables that list the chemical compound, for example, chlorinated solvents, acids, organic, inorganic acids, heavy metals, salts, and then they conduct this E96 test at different temperatures, for example, 38 degrees Celsius, 70 degrees Celsius, and whether the geomembrane is chemically resistant to these common chemicals at different temperatures.
Okay, so what are the applications where chemical resistance is important?
Some of the applications are oil and gas development, and I mentioned oil and gas just a minute ago. Oil and gas storage tanks, and these geomembranes perform a very important function around oil and gas storage tanks, and they provide a secondary containment. So if the tank leaks, the oil and gas does not go into the ground immediately. It's contained by a geomembrane, and that's the second line of containment besides the tank, for example. Another huge application for geomembranes is waste containment, and it's a variety of waste containment, from construction debris to hazardous waste materials to industrial plants, waste from industrial plants and manufacturing. One area that chemical resistance is not important, but geomembranes are used greatly, is water storage. So in a water storage application, especially if it's potable or drinkable water, for example, reservoirs, ponds, water conveyance canals, chemical resistance is not an issue. It's a potable water. We are going to drink it. So you do not need a highly chemical resistant geomembrane for a potable water canal, reservoir, or pond. So pretty much any geomembrane will work in a potable water situation. Other areas where chemical resistance is not important are recreational features. For example, waterfalls, ice skating rinks, things like that. Golf ponds, the water features on golf courses, they're generally
Right.
always lined with a geomembrane, so to reduce the amount of leakage from the golf pond. So if it's water storage or an application where chemical resistance is not important, the key design aspect is ease of installation, durability, performance, how well it'll perform, and of course cost has to somewhere figure in on that application.
Sure. So are there any other important properties of geomembranes that should be considered in design?
Yeah, there are a number of other important mechanical properties for geomembranes, and I'll just mention a few, and some of these can be a topic of a future podcast, such as tensile resistance and elongation. In other words, how flexible the material is. If the application is going to involve some movement of the ground underneath the geomembrane, you want to make sure it can elongate and stretch. Next is puncture. Puncture is very important if something will be placed over the geomembrane. And there are a number of ASTM tests to evaluate puncture, which is a whole nother podcast. But I'll just list three of the most common. First is D4833, which is the pin puncture test. So it's a very thin pin. It's bigger diameter than a needle, but sometimes also called the pin puncture or needle puncture test. And this is really an index test because we don't usually see pins puncture geomembranes. It's usually bigger objects, but it's a way to compare one geomembrane with another, and it's very quick and easy. The next is D5494, which is the pyramid puncture test, where little cones are attached to a subbase and the geomembranes placed over top of it and pressurized, and seeing if the pyramids puncture through the geomembrane or not. And that leads to the biggest puncture test, D5514, which is called the large-scale hydrostatic puncture test. And that can be performed with these pyramids or truncated cones as D5494. But another neat aspect of 5514 is you can make a rock pizza where you actually use the rock from your site or other angular material that you're concerned about puncturing the geomembrane, and place the geomembrane over top of the rock pizza, which is a resin that holds the rocks in place. The geomembrane's placed over top and pressurized, and then you see if these rocks puncture the geomembrane under the pressures that it'll be experiencing in the field. A couple other quick important properties of geomembranes are interface shear resistance to evaluate slope stability, and we've had a number of webinars on that early in 2020. So if you're interested in interface shear resistance and slope stability, check those webinars out. And then the next is thermal expansion and contraction, which in short means, does the geomembrane wrinkle a lot? And that's a topic of a future webinar coming up for me. Wrinkles are very important with geomembranes because it makes seaming the geomembranes difficult. It makes performing leak locations difficult. And geomembranes have different thermal expansion and contraction properties. For example, HDPE has a 2 to 3 times greater thermal expansion than some of the other materials that I mentioned, and thus is prone to a lot of wrinkles and problems in the field during construction. So that'll be the topic of a future webinar coming up.
Wow, that was a lot of great information, but I think we have run out of time today. So thank you so much, Tim. Really appreciate it.
Thanks, Jen. And listeners, if you have any questions or would like any additional information, please email me at fabricatedgeomembrane@gmail.com or visit the FGI website at fabricatedgeomembrane.com. So thanks for tuning in today.